Okay, yeah, as we said, we are here together with PositiveBlockchain and Scrypt Media to present you this blockchain introduction. It's blockchain for good. It's meant as a 101. We're not gonna go too strong in details because we want to make sure we don't go beyond 1 hour, hopefully. The idea is also at the end of the presentation to ask you guys if you want to go in the next phase in a more detailed training. Do you want to learn more about the technology, the techniques, or do you want to discuss more about the use case and how do we implement solutions based on blockchain technologies? Yeah, just a few words about PositiveBlockchain. We are a non-profit association, an open source database, media platform, and community of people from all over the world, from Argentina, Brazil, Morocco, France, and so on, who are exploring what technology can do for social and environmental impact. And we have a bit more than 800 projects, which we identify, list, track, try to cluster as well, so that you guys can explore what can we do with blockchain in agriculture and food, in supply chain, in financial inclusion, and so on. So what do? We curate the database, we organize events and meetups, we help startups and organizations. We're currently also working with a development agency, for example, who are working with partner countries to pilot some blockchain cases, for example, in the supply chain of cotton, and many other cases. And we try to do a bit of storytelling to share the more positive side of the nice stories about blockchain and blockchain for good. Some pictures of our happy people. So as we say, you'll meet mainly positive people in the network. These are some quick data about the database. I will not go here too much in details, but it's just to give you an idea. When we list blockchain projects in that space of social, environmental good, we find a lot of projects in the energy area, 14% health, finance and insurance, aid and philanthropy. So these are really more than 50% of the cases, these 4 segments together. Then you have other cases like trade and logistics, which probably is much bigger now. Some of these data are a little bit old, but I think this took up identity and ownership, definitely bigger and bigger, government and democracy as well. Of course, if you look, depending on the regions of the world, that would also be a little bit different. In terms of headquarter, we talk about headquarter of the projects, which could be startups or also any organization launching a project, sometimes also partnerships. So the headquarter is not necessarily where the project happens, but we still have a lot in the US, very technology-oriented country. The UK, Germany, France, Switzerland, Netherlands, Austria. You have quite a lot in South Africa and other regions of the world. So why blockchain for good? Why at all? Why at all should we care and talk about that topic? So we have listed here, kind of the issues you may encounter, we encounter, well, in Europe, although for sure, when we compare situations of countries in between Germany, Afghanistan, Morocco, South Africa, Brazil, these are a lot of different countries. In general, in suboptimal infrastructures, you may have issues related to a weak financial system. You don't trust in the financial system. You have high cost to move money. You have risks related to cash, transporting cash from a place to another, paying your employees. But you also have many people who don't have access to a bank account. So not a very inclusive system as it is traditionally organized. You have a lot of issues with governance and power with centralized institutions or centralized power within one organization, which decides, which doesn't necessarily include citizens and the users in the governance, in the decision making. You have many models with the man in the middle. So it's, for example, the case when you want to send money across the world, that you have to use some intermediaries and men in the middle, which don't necessarily add a lot of value, except taking a good cut, which can go sometimes up to 15% of your transaction. And of course, you have risk of manipulation and corruption because you have these instances of power in the middle. And talking about data and systems, which is of course related to both, you have centralized IT systems, you have a lot of risk of failure points and also cyber risks. And you have in many areas in the financial systems, but also in energy, in the health, you would have thousands of organizations that would all have their own data systems, and they all records about any type of data or digital asset, or also data about yourself. If we talk about the health system, for example, they would all use their own silo system in a way that it's not efficient and not very transparent and not very reliable. Yeah? So when you look at all these issues, especially let's start with the one related with money. We had some events in the past few years. Let me see if there are some questions.
Don't worry, Lucas, I will check the questions and I'll let you know.
Okay, great, because I saw
people raising
keep
their
going,
hands.
keep going. But yeah, especially talking about financial systems, 2007 and 2008, well, there had been a lot of issues about the trust in our financial system. And this is also what helped technology to emerge, especially cryptocurrencies. And I think it's the first real big use case of the blockchain technology in the past years. Yeah, so if we just talk shortly about money, from gold to metal coins, paper money, electronic money, based on traditional systems, we had a lot of people who lost faith in that system and tried to invent new ways that we could share value, and especially in that case, monetary value in a digital secured way. So the concept of digital cash in the way that it's used in cryptocurrency today is not new, but that was really Bitcoin in 2008 with specific white paper explaining the concepts that made it concrete for the first time with very robust cryptographic concepts and ways of working. So that was the appearance of Bitcoin in 2008, which really took up in 2011 to 2014 a lot in the media. And after 2014, you saw a lot of other cryptocurrencies, not only Bitcoin, which emerged with each of them their own use case and their own way of doing, focusing on speed of transaction or focusing on different type of applications. We'll discuss a little bit about that. Yeah? The term blockchain, everybody used to talk about the chain of block, but it really came together as blockchain in 2015. Not many people know that, but that really defines the underlying technology that Bitcoin is using. But today we are talking about blockchain as one technology, which is part of an overarching term. And I just wanted to name it for you to know, which is a distributed ledger technology. There's a lot of people, they hear about DLT and distributed technologies and blockchain and IOTA and other things, and we're a little bit lost. But when we talk about blockchain, it's a technology which is behind Bitcoin, but which is also behind many other technology and protocols and softwares, which enable not only to share, record monetary value like cryptocurrency, but also any type of value and any type of data. Could be contracts, could be pictures, could be date of birth, could be digital records, could be land titles and ownerships. So we will discuss also a little bit all of that in the presentation. Distributed ledger technology is the overall term. Then you have different families. You have the blockchain, and within blockchain, you will have different families. And then you have the DAGs. These are all the technologies that I will invite you to learn more about, but we will not cover today. Yeah, and with that, I will let Khalid cover a little bit more the details about what is actually blockchain. So Khalid, do you want to take over the slide, or should I just?
Well, you can keep presenting if you can just
Yeah, sure.
the next one. Thank you. Okay, so I will introduce quickly, but very quickly, because that's not the topic today. What we do as a company. So we are Scrypt. We are partners of PositiveBlockchain because we mainly focus on technology and positive impact. So the partnerships was making complete sense. We work with startups and companies and nonprofits also on different areas such as strategy and innovation, product development and UX, marketing and communication. And we have also a small academy where we try to teach a little bit of what we do. So it can be around design thinking, product management, and also around technology for example, to go more in depth with the blockchain, AI, etc. So yeah, that was just to say, if you have any question or want to exchange related to those topics, feel free to contact us, and I would be happy to answer or schedule a short call. Okay, so now let's go to the boring stuff in blockchain, because we will talk a little bit about the technical part. So as Lucas said, blockchain, the technology has been created to basically allow value transfer without the need of any intermediary. So here, for example, we have Bruce Willis, who is sending something to Samuel Lee Jackson directly without the need of anyone in the middle. Once the transaction is confirmed, Bruce can send the same thing to Emma. Next slide. So blockchain is basically solving what we call the double spending problem without needing to have someone in the middle to keep track of the transaction and verify if you have this money or this title, etc., before sending it to the other person. So what is blockchain? So basically, it's blocks. So we find blocks first, and each blocks contain transactions. And these blocks contain the transactions that are executed at a certain moment. So we have block 1, block 2, block 3. So each one is generated in time T1, T2, T3, etc. And the blocks are linked. So next slide. They are links to each other's, and they are time-stamped. And that's why we are calling them blockchain, because they are constituting a chain of block. We will see later how these blocks are linked, and we will see also in details what they are, what they have, like which kind of information they have in addition to the transactions.
So
What's
Khalid,
interesting, yeah.
In that case, so you would have in each block, you would have multiple transactions, right?
Exactly. Yeah, exactly.
So in a way that one transaction is a Bruce sending a certain number of, let's say, Bitcoin to Sam.
Exactly. So,
So
there will be lots of transaction from lots of people. So it's not only one block belongs to you or to some other person. It will have like all the transactions that has been executed at certain moments. So as Luca also mentioned, so what's interesting is now is these blocks can contain information about money or value, but it can also contain information about ownership of products. So here, for example, luxury watch, but it can also be a title of ownership of a house, of a land, etc. It can contain information about the different steps needed to produce coffee, for example, or any food, to trace its supply chain. And it can trace the execution of some contracts or documents when they change, for example, the status of a document, etc. So how does it work? Okay, so now we'll really go to the boring stuff. So the cryptographical concepts that are involved a little bit in the blockchain. But don't worry, I will not go too much into details, because I'm myself not a cryptographic expert, but I know a little bit about it, and I will try to keep it quite high level. So we will talk about 3 concepts. So the concepts that are a little bit the main the main concept of the asymmetric cryptography. So it's like we will have two keys, so one private and one public. We will discuss about the signature, and we will discuss about the hash function. Next slide. Okay, so this one will be very fast. So the public, well, all what you need to remember is the public key is public. You can share it publicly with anyone. The private key is private, so you shouldn't share it with anyone. Okay, now what do we do with them? So that's the next concept, is the signature. So if you have a message, you want to send the message or you want to sign a transaction. In that case, to simplify, it's just a message. It's hello, how are you? So you sign it with your private key, and then you generate a signature. And then you go to the next slide. So for me as a recipient of this message, so if you sign it with your private key, and if I have your public key, because remember your public key is public, I can verify with your message and your public key and the signature that you attach to this message. I can see that it's correct. Here we have an OK weirdly formatted because we transferred it from PowerPoint to Google Slides. Sorry about it. But yeah, basically we can verify that it's OK. If you go to the next slide, if I just change the message and if I have the public key, if for example a hacker is changing the message, but then I'm still having the public key and I'm still having the signature that you sent me, I will figure out that the message has been modified. So it has been altered. So that's how it works, and that's why we need signature. We will see later why do we need it in a blockchain, but that's the basic concept of signature in the cryptography.
So
Yeah.
Khalid, if I may interrupt, so this is interesting to understand because if you want to send a transaction of money through blockchain or like cryptocurrency, you have this concept of key, public and private,
Exactly.
and the same way for any type of exchange of value, the blockchain is using this cryptographic concept and key for validation.
Exactly. So basically that's the thing. When you want to send money, you need to sign it with your private key, with your own private key to verify that it's your money and that it's your wallet. And the other person can just verify it by having your public key, which is public. So they can verify that the money you sent belongs to you. And
So
then it
don't
can be
lose your
added.
private key.
Exactly. Don't lose it and don't share it even with your best friend. And for the funny story, I think there are millions and millions of dollars of Bitcoin that are lost just because like some grandparents or some grandma or some people lost their private keys and now they cannot be retrieved anymore.
You can be young and smart and also lose your keys. So
exactly. I have the feeling it's happened to you, Annie.
not yet, not yet.
Okay. Okay, so the next slide, I think we will be talking about the hashing function. Yes, so the hashing function is another cryptographic concept. So basically, it's just a function that is taking any message in as an input and giving you a chain of character as an output. So the interesting thing here is if you have that's again for the simplification. If you have like just a message here like hello, how are you? You will have a hash. If you just change a little bit, if you just add a question mark or something, you will have a completely different. So you will not have the same, but then you will have the 2 or 3 last ones difference. You will really have completely different different hash. So it's starting with D4 and not 7A, etc. And if you go to the next slide, so this is interesting. Well, here if you want to really know how it works, but good luck with that. So basically it's just taking like the message, the file, the data, and it's really scrambling the bits, and then it's giving you a chain of character in the end. So you don't need to know exactly how it works. What you need to know is in the next slide that the result has always the same length. So for example, if it's a hashing feature function giving you 64 character or 64 bytes, it will always give you 64 bytes. You can enter like a file with 2 words, but you can also give it a video of 2 hours. It will still give you the same length output. And then it scrambled the bits, like what we've seen in the previous slide. It's really making its magic and then giving you a completely different character. And then, yeah, it minimizes duplication. It means that it's very, very difficult, not impossible, but super difficult to have 2 different messages or 2 different data in input and giving you the same hash result. So that's what we call also collision. So we don't have collisions. We don't have two different messages giving the same hash.
So here it's also a little bit, it's a little bit abstract as well, but again, understanding the hash is important because it's a cryptographic component that has a strong meaning in the blockchain, in the way it would make it impossible if you have the hash of a block to know what is the content.
To know what was the message, yeah, exactly. Yeah. That's it. Okay, so next is a demo, just to understand a little bit how do we use all these cryptographic concepts and the chain, what is on a block, for example, etc. I don't know if I can share my screen right now. I will try to do that.
Yeah.
Yes, I will stop your screen.
Yeah, sure.
Okay. So, well, there was a link in the previous slide, so you can get it back there when we get back to the slides. So basically, this is a website that is allowing to have a kind of demo of Bitcoin, or well, it's not really Bitcoin because we have dollars here. But basically, this is a block. Each block is having 5 main information. The first one is the number of the block, the ID. So we have 1, 2, 3, 4, 5. In real life, of course, now you will have like thousands and thousands in Bitcoin, for example. You have the nonce, which I will explain later. That's the transaction. So all the list of transactions that's happened. In a blockchain, you will not have them formatted like this. So you will have like some weird data. It's like not really understandable, but yeah, for this demo, it's quite clear here that Darcy is sending to Binley $25, etc. Here, the 2 here are hashes. So that's the function we saw previously. Here is the hash of the previous one, which is 0 because this is what we call the Genesis block. It's the first block. It doesn't have a previous one. And this is the hash of this current block. So when we go to the next one, we have the previous block is the same as this one. So, and that's how we are linking the blocks. That's how we are having a blockchain. So each block is having the reference of the previous one. That's what's built in this chain of blocks. Now to explain the nonce, I don't know if you noticed this, but all these hashes are starting with 4 zeros. In this one, it's 5 zeros, but that's just a coincidence. Usually, in this case, it should be 4 zeros. So the nonce is something that we add to the block. I know it's going to be confusing, but I'm sorry about that. It is something that we can add to the block so that the hash of this block will start with 4 zeros. It sounds very easy, but it's really not, because if I change this, then it's not starting with 4 zeros. If I do this, it's not on, well, now I'm mining it, so it will be 4 zeros and it will find the node. If I keep trying for 2 or 3 or 5 days in a row, I will not find it. I will not find something that will start it with 4 zeros. And that's the mining process. I don't know if you heard about the miners in the blockchain, in Bitcoin mainly. That's what they are trying to do. They are trying to find this nonce. So the hash of the block will start with, well, not 4 zeros necessarily. It changed depending on the complexity, and that's what they call the difficulty of the mining or of the consensus protocol, and it can change depending on there is a lot of game theory on it, and depending on the complexity of finding, like how long do they need to find these nonce or no, etc. So it will change. For this example, it's 4. Yeah.
Can I interrupt just a bit?
Sure.
So, like in a simple way, if this is getting complicated in your hands, you can think about the cryptographic function like if it was a mathematical function, very, very complicated one that has one incognito that is going to be the nonce, that we call it the nonce. So it's a number that put in this mathematical function will give an answer to this function that will start, for example, in this case, with 4 zeros. So if the function was really easy, like say all the data, all the amount of letters that the block has, plus the amount of letter of the previous block, plus x. So you will have to find this x that is going to be the nonce. So the result start with 4 zeros. So actually it's a mathematical, very complicated function that you cannot solve by hand, let's say, not as quickly. So that's why we put a lot of servers that will try to resolve this function that is the mining system.
Okay. So at the end, the way indeed the mechanism like Bitcoin organizes it, so it's not like there's someone sitting here and doing the arbitrage and saying, okay, you validate a block, you validate a block. It's software that is automatically running. And there are a lot of people with, these miners, they're basically all competing. They try to stack the big computational power with a lot of hardware equipment, which costs a lot, which burns a lot of energy in the case of Bitcoin, in the way it was, what it has been done up to now. So basically they are competing like in a lottery to say, I want to be the one that can try again and again and again, to make the algorithms turn to solve the function, because then I will be the one who is validating the block, and then I will get as a reward some Bitcoins that will reward my work and the investment I make. And this competition, it's completely random process at the end, because there are thousands and thousands of people around the world which are trying and competing, and it makes it really random to know who will validate in a way that there is no central organization that will control all the mining and that will be able to corrupt and change all this data.
Yeah, sure. When we say miners, it's not like few people mining something. It's a lot of computing power, lots of servers and computers fighting to find these nonce, because the one finding these nonce is the one also validating the block and getting the reward from the bit, like getting Bitcoin for it. So yeah, thank you for for saving me, because I was struggling to explain this part easily. The next thing is, let's suppose we want to change this. For example, let's suppose that's why also Bitcoin is quite, well, blockchain in general is quite secure, and it's quite difficult to change the information in the blockchain. So let's suppose I'm coming here and I'm hacking this. I'm Jackson and I want Madison to send me more than $5. I want her to send me 6. So what's happening is that the hash is not starting with 4 zeros anymore. So I will need to mine it. So I need to mine this one. However, it might take some time. If I mine it, this one will still not start with 4 zeros. Then I will need to mine this one also. And I will need to mine, now my window is blocked because even this small example is spending a lot of time to mine it. But yeah, basically I will need to find the nonce and to mine again all the next blocks, which is just, well, I wouldn't say impossible, but almost impossible, because it will mean that I will need to have more computing powers than all the rest of the network. So I will need to be able to mine all those blocks before all the other participants in the network. And in the meantime, there will be some more new blocks come in, so I will need to mine them again. So it's just almost impossible. So that's how blockchain works, and that's how it's secured. Yeah, and that's how it's using the cryptography concepts. And
we have a question: how many blocks in one transaction? So the thing is, it's how many transactions in one block. Yeah, so here you see in this block number 4, there are 1, 2, 3, 4, 5 transactions. Typically in a Bitcoin block, I think there should be more, but a few thousand transactions.
Yeah, much more.
2 to 5,000. It depends also on the usage of the network, but it could be, let's say, 10,000 transactions in one block. So basically, the miners, the network automatically collects all the requests for transactions. Like you have users of Bitcoin around the world, they want to process transactions. These transactions, they stack up, and the miners automatically take a bunch of these transactions in a block, and once the block is validated, in the case of Bitcoin, it's every 10 minutes. Once the block is validated, it is processing these 10,000 transactions. It's not much if it's 10,000 for 10 minutes. There are other types of blockchains and cryptocurrencies which are computing 20,000 per second. Visa, the banking system of Visa is about 25,000 per second with plus and minus. But so you see in the Bitcoin, this is how it works. Again, what we're talking about about mining and the way of validating, it's the case for Bitcoin. There are other protocols, and I think Khalid will talk about that, which are validating the blocks. Perhaps Khalid again. Mohammed asked in the chat how a block is validated.
So can I answer this one?
Yes,
so
sure.
Thank you. So actually what Khalid was explaining before is like we have this big, very complicated mathematical function that is very difficult to find the answer for. But the particularity of these hashing functions is that it's very difficult to find the answer, but once you have the answer, it's very easy to check that actually the answer is correct or not. So as soon as one of the miners or one of these computers that are going to be trying to solve the function says, okay, I found this answer, and they say, okay, I want to be the one solving this block, then all the other miners can take this answer, check very easily if it's valid or not. And then when a couple of other miners have said, yes, this actually this number is a good answer to this function, then the block is validated, and then we can open a new block. I don't know, Mohammed, if this is clear.
Yeah. So this is all the game of the blockchain, actually.
Cool.
This is really everything about that is if everybody has access to the blockchain and can add information, then it doesn't change from our normal systems, and everybody can corrupt it. So again, how do you make sure using cryptographic concepts that you are securing the systems against corruption or against people who are putting false information in the blockchain? In the case of Bitcoin, they organize a sort of like algorithmic lottery because it's almost random. And the participants, the miners, they are the essential part to be granting that security in the network by validating the block. But again, there are hundreds of thousands of people having computers, having a complete farm of computers and servers and equipment. And one of them will eventually solve it, but we don't know who. And that's so random, that's so randomly organized that they cannot correct.
I will interrupt you, Luca. Now there's an interesting question from Maria. Well, the thing is, blockchain, well, just for those who didn't read it, she's asking, she said, when the block is validated, we move to the next block. I did not get why we need to move to the next block. Actually, the blocks are generated, as Luca said, for Bitcoin, for example, they are generated each 10 minutes. So we need to move on to the next block because we have like one block will contain only the transactions of the 10 minutes that's preceded the generation of this block. So then we need to move to the next block, and then we need to chain because let's suppose blockchain is just one big block, then it's not a blockchain. It's like one big block. Then it's easier to just modify it and change it, and then we just need to revalidate this one block. So that's the whole concept of blockchain. So we really need to move on to the next block and to have new blocks generated each 10 minutes or each few seconds, depending on the blockchain network we are using or we are participated in. So yeah, so basically that's the concept of blockchain in itself.
And also blocks have limited capacity, again, depending on each blockchain, but they cannot have 1 billion transactions. And perhaps there are so many people who are using Bitcoin that they really want their transactions to be validated. So once you're busy validating, let's say 10,000 transactions, and you validate them in a block, which is linked in time, there's a timestamp to all the blocks. So when you see here block number 4, there's also a time, today at what time, and so on. Once these transactions are validated in the block, then you need to take care of the next transactions that are waiting. And if there is a congestion in the system and there are so many people doing transaction with Bitcoins, then you perhaps have a lot of delay and it will take 1 hour to process your transactions because there are so many transactions waiting for blocks to be validated. And the Bitcoin blockchain is not so good for that, to process millions of transactions per minute because of the way it's made, with one block every 10 minutes and quite limited capacity in terms of transactions.
Just to clarify, because I think I'm confusing a little bit in the demo, like all those blocks, they are done. Because here I just came late to the party because the 5 blocks were already generated. They were already done. At the beginning, there was only this one, like the Genesis. Then when we mined it, the second one has been created. So just to answer to Maria, because she's saying, but Genesis block isn't done.
Yeah.
So yeah, we generate unlimited blocks. So the blocks will keep getting generated forever. And then we can go back on time to see when the transaction happened, etc. But yeah, basically that's
but so
exactly.
the point is if we are right now at block 5, let's say we are right now at block 5, just what you need to understand is all the previous transactions that happened before, they will be registered in previous blocks, and it's impossible to change the data in the previous block. So to say that instead of receiving 10,000 euros, you received 50,000 euros, or you send it to 2% at a time, because if you're changing this historical data, it will change your hash and it will make your current block 5 invalid, and everybody in the network will see it because everybody is synchronized in the same time. All the miners, all the validators, they're synchronized in the same time with the blockchain. So they will see that someone has tried to change, they will refuse it, and that will not work. And that's the way that you make sure all the historical data cannot be forged and corrupted and changed.
Okay.
All right, let's move on. But yeah, good that there are questions.
Well, feel free to ask questions, because I think it's super important also to make sure that it's understood and all. But yeah, let's move on, because I also think that the use cases are quite important.
Sure.
So I was done with my demo. So if you can reshare your slides, Luca, please. Okay. So well, it disappeared. Okay, sorry. So now I will talk very quickly about the consensus protocols or mechanism. We've seen one. So the nonce generation is what we call the proof of work consensus protocol. So that's what the miners are doing to make sure that the block is valid, and to validate the block and to add it to the blockchain, and then it can be validated. It can, like, the other participant can validate that this block is correct and that the nonce is good, and that the miner did the work. That's why we call it proof of work. But as Lucas said, this protocol is quite consuming. It's consumed quite a lot of energy. It's quite secure. It's very secure, and it's really allowing like almost complete decentralization, but it's consuming a lot. So there are some other protocols, consensus mechanism. I will not go into details because that's not the topic here, and we will need like 1 more hour for this. But I would just encourage you, if you're really interested, to check those 3, or just to type blockchain consensus mechanism on Google, and then you will have a list, and then you can see a little bit what's happening there. But basically, some of them are able to are adding more speed. They are consuming less. Some of them are having less decentralization, so they need like more control, like some people who will control the blockchain, etc. Well, people or organization, but basically each one is having its like pros and cons. So I will invite you to check them in details if you're interested. The last concept I would like to talk about briefly is the concept of smart contracts. Until now, we saw blockchain is able to record information or transaction, but nothing else is happening in the blockchain. So, smart contracts have been first implemented in Ethereum. Ethereum is the second biggest blockchain network after Bitcoin, of course. And it's adding the ability to have software and logic running in blockchain. So for example, here, instead of sending transaction directly to someone, to another person, it will be sent to a smart contract that is hosted in the blockchain. In case of Ethereum, we have what we call the Ethereum virtual machine. So it's hosted there, and it's hosted in all the nodes. So it's decentralized virtual machine. And the smart contract will execute some logic, usually checking if some conditions are met. And then depending on the result of the execution, will trigger the transaction to the other person or to many other people, for example. So here is a more concrete example in the next slide. Okay. So for example, here we have a customer who wants a developer to develop a website. So the customer will send the funds to the smart contract, which is here. The developer, the smart contract. So in the smart contract, we agree about the amount and also the conditions that needs to be met. The developer will develop, and then when it's complete, the smart contract will automatically trigger the payments. And also, if needed, there might be like a smart contract for reputation management for the development for the developer, for example. So yeah, so that's basically smart contract. It's just code software that is running in the blockchain, like decentralized. So it's not like one server hosted in Amazon Web Service, for example, or in a server in the platform in the building of a company. It's small code running in the blockchain.
So basically, Khalid, if I understand correctly,
I know you do.
These are like mechanisms, let's say activities which will run one by one. So like a process, like you would have in any contract. Yeah, as you say, the developer completes the work. If it's not complete, he goes back. If it's done, it's transferred. So all these conditions, they are set before, right?
Yeah.
So the customer and the developer, they have to agree on the rule. They would write their smart contract like a normal one. And once the condition are implemented, so once the work is completed, what is the key feature of a smart contract in that case?
The key feature is that it will block the amounts and it will trigger the payments when conditions are met. Automatically. So it will avoid, for example, if I'm a customer, if I'm a developer, it will avoid that I will have a contract and then I'm not getting paid because the customer is arguing about something or doesn't have the money, like he had the money 3 months ago, but then when I finish the development, he doesn't have it anymore. So it's taking more time to get paid. Here, it will require that they will block it. What's happening now is you have platform for this, but they are still centralized platform. You have some freelancing platform that are also blocking the money from the customers. And then when the work is done, they will check and then they will trigger it. So it's still well, not manual, sometimes they automate it, but it's still, you still need the middleman who is taking like a percentage. Usually it's quite a big percentage, it's like 10, 15, 20%. So yeah, with this kind of scenario, if we are using blockchain and we are using smart contracts, we will have less fees to pay. So if I'm putting $10,000, the developer will probably receive 9,999 because there might be like $1 for the smart contract for the payments of the in the blockchain to pay the transactions, for example. But yeah, it will be quite small compared to some centralized platform for freelancing.
Yeah. So it's a bunch, because someone asked in the chat, is it if and then this happens? So that's exactly the smart contract.
Yeah.
And all these transactions and the logic, like the code, it's written, the smart contract is written as a code, like a logic. So all of this is recorded in blocks, and all the transactions, for example, transactions of money, but also transaction in the sense of the work has been completed, yes, that's the data, that's the validation that you could record. All of this is recorded in the blockchain, also in a way that it's secure, that it's automated, and that it's self-triggered.
Exactly.
All right.
Okay. Here I will try to go super fast in the two last slides because we still need to see some use cases, because now we are too much in the theory. So here, just before going to the use cases, we have, sorry, I would not call them advantages, but more characteristics of blockchain. So the first one is, as we say, decentralized. So yeah, that's cool to be decentralized. We don't need the middleman to execute transactions or to take fees, etc. I'm not saying middlemen are bad, not all of them at least. I'm just saying that blockchain allows us to remove middlemen, or at least to reduce them and to reduce their control or their power. And it's also allowing to imagine new decentralized way for governance, for example. The second one is traceability. So transaction, as we said, are time-stamped. So each block is time-stamped and the transactions themselves are time-stamped, and we can trace them in the blockchain. Transparency, it means that the data in the blockchain are transparent, and anyone can confirm that the transaction has been done, happened in the blockchain. Again, is it really good to have transparency, that much transparency? Well, I would say it really depends on your use case and what kind of data you're putting on the blockchain, of course. If you have confidential data, you shouldn't put them in the blockchain. Secure in the way that without a middleman, we still manage to have secure transaction, and if we want to hack or modify the data, it gets super complicated in the blockchain. While when you are a middleman, it's a bit easier to hack the server or to have someone working like an insider, having access to a database and modifying it or hacking it, etc. Yeah, and that's it for this slide. I would move to the next slide quickly to just, and promise that's the last one, because I think I said the last thing 3 or 4 times. Just here to show a little bit the difference between the different blockchain, type of blockchain. So we have, in one hand, the public networks, the public blockchain like Bitcoin, Ethereum. It means that anyone can join the blockchain, can participate, can like install a blockchain node in your computer, laptop, etc. And you can participate in the network. So you can see what's happening in the network. You can even mine, you can participate, you can validate nodes. In the other hand, we have private blockchain that are mainly used by organizations, enterprises, companies, like NGOs, etc. When they start having a lot of partners and they want to have their own private blockchain. So it's a blockchain with few participants. So it's not, you are not, like, as an individual, you are not allowed to join or see what's happening there because they might have some confidential data in their blockchain. So yeah, I think I'm finally done and I will like hand back the floor to Luca and Annie and Rika to present the rest of the presentation.
Yes, and again, guys, just as a reminder, so thank you so much, Khalid, but as a reminder, that's very basic training. We could go on for 3 or 4 hours to detail and go into every steps, and actually would be happy to do it. So we will share later on a link to a survey or like a Google form where you can also register and tell us what would you like to do in the next step. If you really feel like explaining, like understanding all this concept in a very detailed way, yeah, feel free to tell us and we'll be happy to organize the next session, which is more details. We know there's, for some people, it's difficult to grasp such complicated concepts. At the end of the day, you don't need to understand everything. Like you don't need to understand every web concept to develop a website. You don't need to understand every protocols to send an email. It's the same way with blockchain. Yeah, but still, I saw messages about writing a smart contract, understanding all these concepts, learning how to code and develop. There's a lot you can learn, and we'll also have one slide at the end to give you some hints where you could learn further. So talking about application, we talked about Bitcoin, we talked about cryptocurrencies, exchanging money. There are potentially billions of users concerned. This is the first step of the use case of blockchain. It's using as a cryptocurrency for payment, for trading, for remittances in countries like Afghanistan, in many countries like we see in Africa, in South America. There are issues about sending payment to your family, to other countries, paying salaries to employees, moving money around, and that's still a very strong use case. So thinking really about the cryptocurrency, perhaps using it also as a community currency. There are a lot of interesting applications about that. Then you have pegged services, where you also have hundreds of thousands of cases. So registering identities, or at least access to an identity, naming, ownership of land, ownership of a website. That was one of the first use case, was to register the ownership of website domain names and domains through the blockchain. Yeah? That could be a case if there is a lack of trust and transparency in that system, to use the blockchain for that purpose. Or voting. You know that voting is a big topic nowadays. If you remember the demo we had with all the blocks, if you can safely onboard people in the blockchain and verify their identity and keep their vote anonymous but registered in the blockchain, you could avoid frauds and manipulation and increase the transparency of voting systems. There are a lot of applications about that and democracy in general. Then you have the smart contract. So now we talk more about processes and workflows and activities which involve verification of data, verification of work that has been conducted, and a little bit more complex way of using the blockchain. But for where you would have millions of use cases, because that's simply the way people and organizations work together, right? It's not only about cryptocurrency, it's really about the exchange of work, the exchange of value that you have with multiple conditions, which will determine the next step. Yeah, that's why we use a smart contract. And then combining a little bit all of that, but applying it especially on governance principles. So what happens if 60% of the people in our organization decide for this over this other decision. Is the decision implemented, and what does it mean? It's also a way to managing organization in a way that you don't need a manager anymore. So in a way, you could have decentralized autonomous organization of these so-called DAOs. Yeah, and this is also a case that you could apply for NGOs, for open source communities who are developing softwares, but also for other type of organization, even commercial and private companies could be organized as a DAO. Yeah, so you have here 4 types of levels or types of application that could be used with blockchain. We have few cases, we will detail 2, so Sentry and unblocked cache. That would take about 5 to 6 minutes probably, and then we'll keep another 5 minutes just to list a few names of cases that you could write down and learn more about because we think they're relevant. Okay, Annie, can you tell us more about Sentry?
Yes, thank you, Lucas. So as Lucas said, we included in each of the slides, at the bottom of them, next to the PositiveBlockchain logo, there is a link that you can follow, and in those links you can find more information about the use cases that you are interested in. So this project, the name is the Sentry project. It's a project that has been created by Hala Systems. That is a private company. What is interesting about this project is that it's a project that is based on traditional technologies like centralized servers, IoT, social connections to social networks, and uses blockchain as one component or as one technology or component that integrates to the more traditional system. So Sentry is a project that has been created in order to mitigate and record war crimes. So what actually does is that as soon as an IoT or a person, a user, or someone on a social network points that there is going to be an airstrike in a certain part of Syria or at a certain time, this information is going to be collected and then is going to be published as well. So the people that is living nearby, they are able to evacuate their places to reduce the risk of getting injured. So actually, this information, well, as I was saying, Hala System is a private company. Even though what they are doing is to help society, and what they are trying to do is to help, in order to, as all this information and all these reports are written in a centralized server, if at some point this information wants to be used for prosecuting the people that are perpetrating these attacks, the judges judging this information, they can claim that the information may have been tampered by Hala System because they own the servers. So actually, they joined with Consensus. Consensus is a company that works with blockchain exclusively. So they joined with Consensus. So using this pegged service or use case that Lucas was explaining before, what they do is that as soon as a report is created on the Sentry servers, they will create a timestamp and a geolocation that is going to be associated with the hash created from the report, and that's going to be written on the blockchain. So we know that as soon as this hash is written in a public blockchain, it's going to be impossible to modify. So in this way, Hala System can preserve the immutability of these reports. So if at some point they managed to actually have to persecute the people created these airstrikes, they can hopefully use this information as a proof of these attacks and all these war crimes. I really invite you to, I included 2 links on the bottom. So in the one on the left is very easily explained how the use case has been implemented. And then on the right, you have the HALA system webpage. So you can go directly to them and see what are they doing. Now is Rika time.
Yes. Hi everyone. So I'm going to present to you the Unblocked Cash. It's a project that was made by Oxfam in Vanuatu. And to understand like the what happened there is like Vanuatu is one of the most prone lands for disaster. So there's a lot of volcanoes, earthquakes. And when like a disaster happened, it was very complicated to get like physical aid there. So it would take normally an average like 4 weeks or even more to get like some aid there. So they needed to create something that would be faster and also people could directly use and stay like make sure that the help was getting to was supposed to. So and also in Vanuatu they was thinking about like this how do they want to transfer this cash or this donations, and in a place that most people don't have a smartphone, and so they had to create like a solution that was not really dependent on having all this technology around, and also people that are not really banked. So what they did was they get like some vendors that are like participants of the project. They will get them like a smartphone or like an Android smartphone with an app with a dashboard from given by Simple, this platform. They'll partner from Oxfam, and then the beneficiaries will get like a card with a QR code, and then they will just go there in their community and just buy products themselves that they needed. So so this way the money would stay like in the community and we hit up also the economy there. And why did they use blockchain? So for this is because they needed a decentralized solution because imagine if Simple, for example, had to in their platform had to validate every transaction that was made. So they will be very dependent on them. When they are not there, the whole system will collapse. So this whole complementary ecosystem, economic ecosystem they are creating would collapse. And also for transparency, also for audibility, for donors to make sure that the money they are donating are getting to the people they're supposed to. So that was a way for them to make sure that everyone was there, like open for everyone to see. So that's why they use blockchain. And also for them was easy to seamless like control the money they were coming, who are using, how they are using, and make sure that everything was seamless coordinated, let's put it this way. And this solution was it's a very nice solution because it was very user-centric design. So you see that you don't need to have a super high technology to deploy this kind of technology. You can make for places that they don't have like an infrastructure. It's very easy to apply if you make it together with other solutions as well. And so it's a simple tool and rather separated from rather high tech, as I said. And in the link here on the bottom, there's also a link from our platform that you can read more about it. There are videos in YouTube also about it because also about like some prizes. So it's a very interesting project about like how you can do like the deployment of this technology in a very grassroots way.
Yeah, and I think they also provide a lot of documents so that it can inspire other communities to replicate the same. They are involved in pilots in other regions of the world, so good to learn about that. Yeah. Now for the few last minutes, there are some cases which are, let's say, just mentioned. We'll not go in details. I invite you to write down the name and do your research. BitPesa was...
Luca,
yes?
we have shared the PDF, so they don't need to write down, but you can go a little bit faster if you want.
That's a very good point. So BitPesa, it's about crypto exchange for payment, remittances. It was used a lot for B2B companies in Eastern Africa. BitMinutes is the same concept, but they are using telecommunication prepaid minutes as an asset which they digitalize. So they tokenize the prepaid minutes, so that people, they can share token digitally in the same way you would exchange telecommunication or prepaid card, for example. they make it a token to make it better shareable and make it digital. Bounties network, how to mobilize communities through bounties for a good cause. Ben is about registering land ownership. Of course, has a strong bond to governance, which also want to fight corruptions and improve the way land ownership are registered. Then you have Etherisks, is about decentralized insurance protocols. So they are using smart contracts to basically revolutionize insurance, especially for cases where insurance companies are traditionally not interested into small farmers that have, very small piece of land. No insurance company with traditional product is interested because it's not worth it in terms of contract management and claim verification and so on. So they're using automatic claim verification, especially for crop insurance, disaster recovery, and making a smart contract to provide insurance to people who don't have access to it. Very interesting case. They had great implementation in Asia, in Africa, with social organizations as well. Moda is a cooperative cryptocurrency, which is using also crowdfunding concepts for including farmers, sorry, in Latin and South America. So as a cooperative for farmers, so to say. Then you have cases for voting, tracking of minerals. MineSpider is an interesting case. They did a lot for cobalt tracking in mines to make sure that for example, car manufacturer are not using minerals from mines, which is employing or which is using child labor in the mines. So it's also about tracking and traceability of the minerals through the blockchain, providing more transparency and security in the sourcing of materials. Banana coin is a cryptocurrency which is used specifically for banana agriculture. It's also adding a funny touch. Who would know banana coin would be so popular? But basically they're raising awareness, creating a community currency, and people can trade locally better using this banana coin, the locally produced banana. Is also a way for them to fight a little bit competition of products which would come from other countries. The UN has worked a lot with blockchain for refugee camps, especially to improve the way cash is being disbursed to the refugees in camps. They are using different technologies in that case, such as eye recognition to identify people on the blockchain. And nobody is using cash anymore in these camps in a way that the UN can analyze what people need, what they are consuming. They can remove the local banks, which were sometimes also failing in terms of corruption or taking a cut of costs for organizing all the cash transfers to the people locally. So now it's all done virtually through a blockchain. The UN is also thinking of using this as an overall infrastructure to better know and serve the refugees when they move from a country to another, or when they move from a UN agency to another. Yes, many solutions exist for money transfers and remittances. Energy is another case, creating incentivize or raising funds for better energy solutions or renewable energies, but we're not going in details here. Yes. All right. Annie, perhaps you want to present the last slide about some free learning resources that people could use. It's not exhaustive, but it's a quick list that you curated.
Yes, these are kind of my the favorites of the community. What I would say is, like, if you don't have any basic knowledge of other than this wonderful explanation that we had from Luca and Khalid, I would recommend to start with the online courses. So you have the blockchain specialization. The first one, you have the link there, and then you have one made from Berkeley. So these two online courses are is going to be content that guides you through the concepts. And then if you are interested on learning how to code on Solidity, that is the language in which smart contracts are coded on Ethereum, you have Crypto Zombies. There is an interactive game. I think now you can also learn how to code dApps for Libra, that is the blockchain on Facebook. So on Crypto Zombies, you have Ethereum and Libra courses. And then you have, if you want to go a little bit more into a specific subjects, you have a list of podcasts that you can find online on or in Spotify that are very interesting. You can search by subjects, and if you are a bookworm, then you have these two books that are available in English that are very interesting and are favorites. The slides has been shared by Startupistan already, I think, if I'm right. And if you need more resources, please don't hesitate to put it onto the Google form that we shared just before, so we can prepare more stuff for the next time.
Yeah, one interesting point from the form is also to understand which use case would you like to learn more about. Is it more about using cryptocurrencies and community currencies, which is a really interesting use case? Or is it more about implementing smart contracts for other use case, like in supply chain, like on some democratic processes, which we know is a critical issue as well. So yeah, let us know about that. You have few options. You have 3 or 4 questions in the form, and you can let us know. Then we can develop tailor-made training materials for a next step. Is there any remaining question? I think we have answered a lot during the presentation, but if there's any remaining question that you have, even if you think it's dumb, don't think that. It's now or never. Otherwise, I think we'll close here. And of course, feel free to reach out to us. You can also follow us on we're bad to advertising ourselves. Oh no, look, not so bad. We have an email address that you can contact us, but I think emails are from the past. So you can find us on Facebook, Medium, Telegram, Twitter, Instagram, LinkedIn. Where are we not? And of course, TikTok, we're not on TikTok yet, but a good thing perhaps also we have we're curating since this year newsletter is a good way for you to stay up to date, learn about new projects, some news, some event invitations. We're trying to do frequent webinars, sometimes which are focused on a specific topic. Perhaps we will do one on identity. We did one on carbon trading in August. And you will receive all of that through the short newsletter. And of course, Scrypt Media for us is a great partner, which is professional and working with a lot of projects and startups. So feel free to get in touch with Khalid if you want to go to the next level.
You can come to take your check.
Just take the opportunity to thank you all for your time. Thanks. You to Blockchain and to Scrypt Media. We really appreciate the information. Of course, it's very complex technology, so this is just scratching the surface, but looking forward to hear more, and we'll definitely have to fill out that type form, the survey, so we can guide you in the next presentation. But that was fantastic and very informative, so thank you for your time.
Thank you for the invitation.
Thank you. Yeah,
thank you for the invitation. Thank you, everyone.
Thank you all the attendees as well.
Yes.
Yes.
Bye-bye.
Bye. Thank you.
Bye.
Bye-bye.